Hey everybody, and welcome to the second lesson of Similarity of Figures unit, and we're going to be looking at 6.1 today, which is similar polygons. Now we'll be starting off with some terms and their definitions, and then we'll be using these terms within the lesson for today. Now the first one that we'll look at is similar figures, and this is going to be matching up with this definition right here. Similar figures are figures that have the same shape but are usually different sizes. Corresponding angles will be the same and corresponding lengths will have the same proportions. The next one we're going to look at is corresponding angles. And that's going to match up with this definition here, which states it is two angles that are congruent and occupy the same relative position in similar figures. Congruent is going to match up with this definition at the bottom, and congruent means the same or equal in shape or size. Whatever you're talking about is going to have the exact same shape and size to it as the original or the matching. And the last one is corresponding sides, and this goes with this definition of two sides that occupy the same relative position in similar figures. So we're going to use these terms within the lesson today, and you're going to get a better understanding of exactly what these definitions mean. We'll start off with looking further at the corresponding sides and angles. So that's two of the terms that we talked about above. Labeling figures can help you determine which sides are corresponding. This will also help you set up your ratios. So we're looking at these two objects first, and we're going to look at labeling angles. So if we're looking at angle A, B, C, and D, it would match up with A, B, C, and D on the corresponding shape. So angle A, and this represents angle A is equal to angle A. Angle B would be equal to angle B, angle C equal to angle C, and angle D equal to angle D. So those would be the corresponding angles between the two shapes. If we were looking at this triangle here and we were labeling it for the sides, we would have X, Y, and Z, and then we'd have X, Y, and Z. So to talk about the sides, we would have XY, so this line right here, as one side, and you would write it as XY. We'd also have that matching with this same line on this side, so we'd write it over top of the other and write it as XY. This is equal to, and then if we were talking about Y and Z, we would write YZ. And if we were talking about this line here, we'd write Y and Z. And last, if we were talking about the bottom line, so this here and this one here, we would have equals to X and Z and X and Z. And that's how we'd write out that bottom line there. So that's looking at corresponding sides, the first part we did, and corresponding angles in this. Now if we wanted to talk about the corresponding angles in this shape, or these two triangles, we would talk about angle Y, which would be this angle here, and this angle here are corresponding to each other. This angle here, angle X, is equal to angle X on this one over here. And then Z and Z, so we'd have angle Z equal to angle Z. So that would talk about your corresponding angles on the triangle. In example 1, What are the lengths of the enlarged diagram? So important here, it says enlarged. So we know that it is getting bigger. In the new diagram, if the new diagram is enlarged using a scale of 1 to 2, what is the measure of each angle? So notice how we have an angle here of 120. We have to figure out what this angle would be. It says label the diagram with the new measurements. Well, important is if you are copying this correctly and you're enlarging it correctly or even reducing the size correctly, the angles are always going to be the exact same. So that means if this angle is 120 in the top left there, this would be 120 as well. 120, and all of the angles are 120, so that means that it would copy the exact same angle. If you do your shape correctly, none of the angles should change with their corresponding angles. So all corresponding angles would be the exact same if you enlarge it or decrease the size. Now the difference though would be the lengths of the side. These can change. So if we're enlarging this object and we have a scale factor of 1 over 2, well, we want to make sure that we are getting a bigger number. So our number should not be getting smaller if we're enlarging this, meaning we have 5 on top and x on the bottom. This will give us 1x is equal to 2 multiplied by 5, so x is equal to 10. So that would be our lengths for the side. So all the sides are going to have a measurement of 10. And don't forget our units of feet. So all of our units would be feet on all of these. And that's how you would enlarge your object if you are enlarging it by a scale of 1 to 2. In example 2, Debbie works for a magazine and is adjusting the dimensions of some images to fit into an article. She is not certain that she has changed the length and width by the same amount and wants to find out if she has used the same ratio for each direction. Now on the left here, we have our original, and on the right we're going to have our scale. A says we want to first look at the original photo on the left and the changed image, so our scale on the right. What is the ratio of the lengths? So we're trying to find, well, if we look at this one and this one, so our lengths on the top of our original and on the scale, what is our scale factor going to be? That we would find our scale factor is having our scale over our original, which would mean we have 6 because on the right is our scale, over 4, which is our original, and we want to make sure that this is to be the exact same for our width. Well, we have 6 over 4, and we can reduce this to 3 over 2. We could also take this further and reduce this to 1.5 over 1. If we're looking at our ratio for width, we have our scale over our original, which is going to be 3 over 2, which matches up perfectly. And if we went further, we'd also see that the 1.5 over 1 is the exact same as well. So that can determine that has the same ratio been used for both cases? Yes, because if your scale factor, so this number that we found here, ends up being the same, then your scale factor is correct, and that means that you've done your ratio correctly. Now, are the two photographs similar to each other? Explain why. Well, yes is the first important part, so yes they are. This is because the sides are scaled by the same ratio and the angles are congruent, meaning that the angles are the same. Because we have our 90 degrees in the corners and they are congruent, so they're the same on each shape that was drawn. Example 3 says a family wanted to recreate a front yard garden into their backyard that had the same shape but was larger in size. They created a map of a trapezoid that would fit in their backyard. If the family uses the plan they have sketched for the new garden, will the shape of their two gardens be similar to each other? How will you determine this? And the hint that they give us is to look at the corresponding angles and to look at the proportions. So if we're looking at these gardens here, we have our original garden, which is in the front yard, and they want to make this scale one in their backyard that is slightly larger. First thing that we can look at is, are our angles the exact same? Well, if we have an angle of 109 here, it would correspond with an angle that would be right here as well. So it's going to be equal to that angle, so we would have 109 here. Well, we have 109 here, meaning we'd have 109 here. So our angles on the bottom are the same. We have 71 at the top and 71 here, which would be corresponding. So we'd have a 71 here. Let's do a different color. 71 here, and that matches with the 71 over here. So our angles are all corresponding, which is perfect start to know that these are drawn correctly. The next thing that we should look at is, do the lengths of the line follow the same scale factor? Well, we can do our top and our top. So if we go 20.4 over 13.6, and we do 20.4 divided by 13.6, we will get 1.5. If we did our side length on the left, so of 10, which would match up with this 15 over here, and we did 15 divided by 10, we'd get 1.5 again, showing that our scale factors are the same. And we could triple check this by doing our bottom, which is 10.8 and 7.2. So 10.8 over 7.2 equals 1.5 as well, knowing that that'll give us the same scale factor, meaning that these gardens are the exact same, just drawn to a different scale. If you were asked this type of question on an accountability check or on a test, these would be the steps that you need to follow. So you want to make sure your angles are the same, and you want to make sure that your scale factor is the same, which would be your proportion. Looking at example 5 now, we have Tara has drawn a scale diagram of her bedroom so that she can sketch different arrangements of her furniture. In her diagrams, the walls have the following lengths. So we have A, F, E, D, C, and B, and all the lengths are given for you. The next thing says, if the longest wall in a room is actually 12.75, and remember that this means feet, so we have 12.75 feet, how long are the other walls? So we know that the longest wall, which is A, 8.5 inches, is really 12.75 feet. So the way that we're going to calculate for all of the other lengths of the wall will be to set up our proportion and then substitute the known values to find the new wall size. So what we have is our scale over our original. Now that means that we have a scale which is 8.5 inches over our original, which was 12.75 feet. to make this easier to work with, what I'm going to do is get this all under 1. So I'm going to divide this by 8.5, which will get my top being 1, and divide the bottom by 8.5, which will get my bottom being 1.5. We have an easier number to work with to calculate for all of the other sides, though you could use the original scale as well. Now this was for A. We want to find out for B. So if we follow that scale factor of 1 over 1.5, which is equal to, and we look at this length for B, which is 6, we have B over X. So we're trying to find for X right now, or I guess we could call it B in this situation. So we do our cross multiplication of multiply and multiply. And what we're going to get is B equals 1.5 times 6. So B equals 9. And that's going to be 9 feet. So that's what the original would be. If we were calculating for C, we'd have our same scale of 1 over 1.5 equal to 6.5 over C. And remember, we know exactly where these numbers go because our top is in inches and our bottom is feet. Our top is in inches. Notice the inch on the 6.5. So that stays on the same height. So you always want the same measure on the same position. So if it's the numerator, it's the numerator on the other. If it's the denominator, it's the denominator on the other. Now what we get is our cross multiplication. So we have 1C, or just C, equals 1.5 multiplied by 6.5. 1.5 times 6.5 gets us C equaling 9.75, and that's feet. Now we can calculate for D. So we'll have D equals, same ratio of 1 over 1.5, because that's our scale factor, is equal to, D is 2.6 here, and that's 2.6 inches, so that goes on top, over D. We do our cross multiplication, we get D equals 1.5 times 2.6, so D is equal to 3.9 feet. Now we have E left to calculate for, so we have E, and it's the same ratio of 1 over 1.5, equals, E is 2 inches over X. Do our cross multiplication, we get X equals 5 multiplied by 2. So our E equals 1.5 times 2, which is 3 feet. And our last one to calculate for is F. And it's going to use that same scale factor of 1 over 1.5 equal to 3.4 over F. Take this further. We do our cross multiplication. F equals 1.5 times 3.4. So F is equal to 5.1 feet. Now, what we should walk away with of an understanding is that if we know that the dimensions are all drawn correctly and the shapes are similar, if we have two corresponding sides, so our 8.5 inches and our 12.75 feet, these can set up our scale factor to calculate for all of the missing lengths that we don't know. And that's just from knowing two sides that are corresponding. In example 6, we have if these two shapes, take out that, if these two shapes are similar, find the length for X. So we have 21 matching up with X and 32 matching up with 8. To find our scale factor, we always have our scale over our original. If we call this our original and this our scale because we're trying to find our shrunken object, we would have 8 over 32, and then our corresponding sides on the top would be x, because that's our scale, and our original was 21. Now what we've set up is a cross multiplication to solve for our unknown value. If we cross multiply, we get 32x is equal to 8 multiplied by 21. We need to do the 8 multiplied by 21, so we have 32x equals 168, and then we need to isolate x, so we divide by 32 and divide by 32 on the other side to cancel it off on our left-hand side, and we'd get 8 equals 5.25. And there's no measurement or unit of measure given, so we just leave it as that for our final answer. So we've looked at a couple different terms and their definitions today, and we really looked at using scale factor to solve for missing sides. If you have any questions about this, please send me a message on Teams or ask me in class. Other than that, have a great day.